So when an object is falling to the earth, it's said to be at free fall. Now we know that the acceleration of gravity on Earth is 9.81 meters per second squared. This is ignoring any air resistance or other factors. Okay? The value of 9.81 meters per second squared is our average value on Earth. But the acceleration due to gravity does vary slightly at different locations. But we are just going to assume, for the purposes of our questions, that it's always 9.81. If air resistance is ignored, all objects will fall at the same rate, no matter what their mass is. This means that a heavy bowling ball and a small marble will hit the ground at the same time, if dropped from the same height exactly. The acceleration due to gravity is still a vector quantity because it's still acceleration, okay, and needs a direction. The acceleration due to gravity always pulls objects to the center of the Earth, so down. So normally with our conventions, with our velocity vectors and displacement, we would say down is a negative, correct? But, so this is an exception, with these free-falling questions, we're always dealing with gravity and things are always going down. So for several of the questions, and I'll point out which ones when, we just will say that the direction, like we'll just say acceleration is positive if everything is just going down. Okay, and I'll clarify that with examples. Terminal velocity. This is the greatest velocity an object in free fall can reach and occurs at the point when the object is just about to hit the ground. So what do these vectors look like? So we can either look at when an object is just dropped from a height, just let go. An object is dropped. Or when an object is thrown up and it has to come back down. So these are two different things and we need to look at them a little bit differently. So see here, if we start, this is like our A point. This is where we're starting from. So let's call this A, this is B, and this is C. So my velocity vector at A, when I start right from the beginning, it's 0.0 meters per second. I think I need to align my board. Excuse the interruption. Okay. VB okay, is going down. So when we start, our initial velocity, or in this case VA, is 0. Okay? C, or VC, will have a bigger arrow down. When an object is thrown up, so when I'm starting, say I throw a ball up in the air and it falls down over here, so I'm going to label this A, B, C, D, and E. So I have my vector for VA. I just draw an arrow up because I'm throwing the ball up, so the velocity is going up.
When it goes up, is it a positive number?
Yeah, for when we're doing objects thrown. Yeah.
Okay, and then when it goes down, it's fine.
Yeah. Okay, so with B, again, our VB goes up. And now at our C, we assume C is at max height. And at maximum height, whenever any object is thrown up, at that very top point, velocity, what do you think it will equal? 0. Yes, that was fine. Okay. Okay, VD, now the arrow's going down. And again, arrow down, VD. Now, there are some relationships we can make here. So say you are given VA and you need to figure out VE. Well, we're going to assume that A and E are actually at the same height. One is just when it's being thrown up, and the other is when it's coming back down. So we can say that VA is equal to negative VE. So as Zach pointed out, this is our positive vector and this is our negative vector. So if we assume that these are at the same height, positive, negative. And then we can conclude the same thing at B. So BB is equal to negative BD because they're at same height. And I'll write that note in here too, because at same height. I'm not done. Note here, the acceleration, okay, so A, our acceleration vector arrow would always point down with the same length at all locations. Because what do I know about my A? A is always 9.81 meters per second squared, pulling the object down to the earth. So regardless of if I'm throwing it up or it's falling down, your acceleration remains the same. Question?
Why is VC arrow bigger than VB?
Here? Because this is closer to terminal velocity, and so the velocity is going to be that much faster.
So you should be the same kind of like your A and B large arrows.
Well, only E would, not A.
When you start throwing something, it doesn't really speed but it travels.
Right. I'm not certain about the length of the vectors for those. Maybe through some examples it might come clear. Okay, at all locations, because our A is equal to 9.81 meters per second squared. I'm wondering, Hayden, for simplicity's sake, if they just assume that A and E would be the same? Like if we're not going the next level advanced with it? That's my assumption, but I might think about that some more. Okay, so let's do a couple examples about how we apply this mathematically. So a large steel ball is dropped from the top of a shelf. If the ball hits the floor with a velocity of 11.7 meters per second, what is the height? So it's dropped from the top of a shelf. What is always my initial velocity when I'm dropping something? Zero, yeah, okay. So for sure I know that. So VI is equal to 0.0 meters per second. And even though you know it's zero, just write in that it's VI, because when you're trying to find your formula, if you don't write that in, then you might be like, well, I can't find a formula that works, so make sure you write in your VI. We know our VF, this is what it's going to be finished with. This is the final velocity. So VF is equal to 11.7 meters per second. And I know my A is 9.81 meters per second squared. So because I'm just dropping something and all my reference is going down, I'm going to keep my velocities as just positive. My acceleration is positive. Okay? Technically, it wouldn't be incorrect if you put negative, but it's just we're saying, we'll make a note here. Oh, and we're trying to find D. So star, let down be the positive direction, because everything in this question is down. Again, it wouldn't be incorrect if you did so, it would work out. Okay, so which equation has VI, VF, A, and D all in it?
VF squared plus VI squared.
VF squared equals VI squared plus 2AD. Okay, I can make this simpler for myself, and I'm just going to cross out the VI squared because that's 0. So VF squared is equal to 2AD. I'm solving for D. So I divide by 2A, divide by 2A. So VF squared divided by 2A, oh my goodness sakes, is equal to D. So 11.7 meters per second squared divided by 2 times 9.81 meters per second square of the units. This should equal 6.977 meters. So to sig figs, this is 6.98 meters. And it just asks what is the height. So I don't need to put a distance.